Good evening, everybody. My name is Yelena. I'm the teaching assistant in the data analytics program. So the purpose of today's meeting is to introduce the R and RStudio, right? So here is today's agenda. We're gonna do a quick overview. What is R and what is RStudio? And we're gonna do an overview of RStudio interface. And I'm going to show you how to save all commands in a script to make sure that the work is reproducible. We're going to go over how to use the variables, how to read data from CSV file, and I'm going to show you what the data frame is. And we're going to look at the data pre-processing, including the subsets, taking filters, applying filters to the data, sorting data, handling missing values, and more. And we're going to do some data visualization. And there is a bonus for people who stay through the end, and for people who watch the recording through the end, there is a bonus at the end. All right, so now let's go ahead, get started. Oops. So here is the data set that we're going to use in this demonstration. And the first column is a data ID, the user ID. And then the next column identifies if the person is a smoker, and if the person's a drinking level, the rest preferences, and more. So here are the individual attributes, so to speak, and the individual weights. But here the weight is not in pounds, in kilograms, different methods. And an individual height and a year when the individual was born, right? So that's the data we will use. Now, what is R? R is a language that we're going to use for statistical analysis. And the one advantage is it's free, it's open source, it's available, and it can run on multiple operating systems, right? So I can share the result with anyone, and there is a nice documentation online. And also you can use R with databases, and there is more than one way to do the same task, right? And it supports parallel processing. Now, there are some drawbacks. All right, so if you're not speaking, let's make sure that you are on mute, all right? So I'm gonna mute everybody. All right, there we go. There are some drawbacks. There is no graphical user interface. Well, unfortunately, it requires some practicing commands, right? And also, our language is case sensitive. For example, if I have a lowercase x and uppercase x, I have two different variables. R may not solve all data mining problems, and you need to keep on updating packages regularly. And then, this is very important, you need to have local admin rights on a PC. So when you try to install the RStudio or R on your PC, make sure that you have local admin rights, or at least the password, admin password. Now, here, I'm giving you the web page, and you'll have a copy of the slides after this presentation. So here is what you need to install. You need to install R, and then you need to install the RStudio. You might be wondering what RStudio is. Well, this is an interface that allows running the commands. It has 4 nice little panels, and I'm gonna use the application shortly. I'm gonna switch to the application, but first it's a little overview, right? So you have 4 windows. The source window, environment tab, right? That's gonna show me which variables I have in memory. And I've got the window where I could see my files, plots, packages, and help files, and I'm gonna go over everything. And the console window, right? So now, here, I'm gonna go ahead and I'm gonna share my screen, and I'm gonna switch to my RStudio. I like to show it as a hands-on. So I'm gonna go share, and I'm gonna share my screen. And here's what happens. This is the RStudio. When you launch it, you're gonna see this 3 tab. First, you're gonna see 3. Global environment. Notice that I don't have anything in here just because I just launched the program, right? And this is a window where I can type my code in a console window, but the problem is I want my work to be reproducible, right? So if I run a set of commands now, I want to be able to run the same set of commands tomorrow. To do that, I have to create an R script. So the way I do it, I'm going to say File, New File, and I select R script. And this is where I'm going to type my commands. This is the editor, commands editor, right? So for example, if I type r.version, right, and if I run this command, it's going to show me the R version that I'm running, right? So I'm going to hit R, and over here, it's showing me the R version, right? So, but if I had to do this command repeatedly, or a sequence of commands repeatedly, I better have it saved as a script. So what I did in preparation for this meeting, I wrote a script that I want to demonstrate. So now I have a script that I already wrote. What I have to do is I have to do file open, and then I have to find my script where I saved it, right? Or alternatively, I'll show you something here, recent files. If you already had your script open, right, suppose that I worked on it earlier today, or suppose that I worked on it yesterday, it's going to be in my recent files, the files that I recently opened. There we go. So here is my script with commands, right? So let me close Untitled, and I don't want to save it. Here it is. Now, you might be wondering what this is in green, the hashtag, and then this line over here, this is a comment. Comment is a non-executable line of code, and the purpose is to document what my code is doing. So that way, when I come back to my code tomorrow, it will be much easier for me to read, it will be much easier for me to edit the code, and also it will be much easier for me to share this with you after this presentation, so that you'll be able to see what Yelena did, right? It's a review. So basically, when you run the R version command, excellent. When you run the R version command, it's going to show you the current R version, right? So now this is an alternative way. We're going to run the session info. It's going to give me the information about my current session, right? So this is the information about my current session, my operating system, and so on. Now, this command is going to list all variables that I currently have in memory. It's going to return nothing at the moment because I have not done anything. Objects is an alternative way to list commands on variable, to list all objects in memory. Right now, the list of objects in memory is still empty. The nice thing about R is that I can use it as a calculator. I can use R as a calculator. Okay? So now this is what I'm gonna do. I'm gonna run this command 5 plus 9, right? That's gonna use R as a calculator. But again, I have not really done anything. My environment is still empty because I did not assign this to any variable. I just output it to the screen. Now what else I can do is I can just print a message, welcome to the data mining. I want to point out something. That's how the R is. Everything is a vector. This message over here is a vector. R is treating it as a vector of a single element, right? That's what index 1 means. This is an index of the first element of a vector, right? So it's a vector of a single element, in other words. Now I'm going to assign 3 to an x. This is an assignment operator. I'm assigning a 3, and this is going to create a variable, right? X equals 3. And if I run this ls command now, it's going to show me that I have one variable x. Now to delete a variable, right, to remove a variable, you can run a rem command, and in parentheses you specify the variable that you want to remove from memory. It's gone. Now here, this command, you want to be a little bit careful, because this will remove all variables that you currently have in memory. ls, right, is going to list all variables, right, and rm is going to remove all variables on the list. This is a nested comments example. Now, what I'm going to do here, letter C stands for combine. So this will produce a vector of 5 elements. And this is very important, you'll see why, because some comments take a vector as an input parameter. It could be a set of colors, for example. It could be a set of attributes. Here, what I'll do is I'm going to assign a vector to an x. It's going to create a set of value 1 through 5 and assign it to an x. And here it is. And here I'm just printing an x to the screen. Now, suppose that I want to print only an element. So that's what it means. It's a subscript, right? This means the third element. So keep in mind that elements in the indexing in R starts from 1. So some of you might be familiar with other programming languages where the indexing starts from 0. Here it starts from 1. So my third element is going to be 3. Now, if I want to see the data type, class command is going to return me the data type of x. In this case, it's an integer. Alternatively, I can do the type of, it's going to be an integer. Now I can do the str command, and str is going to show me the structure. In this case, it's showing me that x is an integer, right? And it contains 5 elements, 1 through 5. Now what I'm going to do, this is another vector, but here I want 1 through 5, and I want to skip 6 and 7 and do 8 through 10. Now I want to display y, and here that means that I want elements 3 through 6. I could list 3, 4, and so on, but I just want to do 3 through 6. Now I want to do the class of y, and it's going to be integer. And same thing, str is going to be the structure. I can multiply by 2, and I can display, right? Now here, this is how you do the sequence. That will create the elements 1 through 10, right? Well, some of you might be thinking, oh, that's so simple. Well, but these are the basics that we need to know to do more advanced commands, right? And here the output. And here I can do the sequence, but I can start from 2, right? I can print it. And here I want to do the increment by 2. Right? I can do the increment by 2. And here I'm just going to output what I have. Now we're going to get a little bit harder stuff. Now we are ready to read the data from the file. Right? What we're going to do is, first of all, we have to set the working directory. Working directory is a location on my hard drive where R attempts to look at when I try to open a file. For example, if I do anything like file, open file, it opens as a documents folder. So this is currently set as a working directory. However, my data set is saved on my external hard drive. It's called an F drive, and I have a special folder. I call it datasets, right? So I'm going to use the set wd command to set this folder as a working directory. I'm going to hit run. And now, notice that right here, on the title bar of the console window, I see what my working directory is. Alternatively, to see the working directory programmatically, I can run this command, get wd. Now this command is going to list the files that I have in my working directory, right? So I have a bunch of files, those are datasets. I'm interested in a file called userprofiles.csv. That's a data that I showed you a while ago. That's a file name. This here means that the first data row in my file is a header. I want the heading, the variable name, to be read from my data file. This is the first row. And this is going to be my variable name. Now, important, make sure that there are no spaces. I put underscore instead of space. Now notice here, I have one data row with two missing values. The value is not specified. I'm just showing it because it's going to be matter. Later on it matters, later during the presentation. Now, I'm going to read this data into a variable called user profile. This is a data frame. The object that stores the data that we just read, it's called the data frame. I can click here on the arrow, and here I'm going to see the structure. Those are the variables: user IDs, marker, drink level, task preferences, ambience, and so on. Right? These are the column headers over here. Right? So now I see the data types here. Factor is a categorical variable. Right? So here you see 3 levels. It means that the variable has 3 valid values. Right? And it tells me what the values are. And here, marital status, same thing, right? I have 3 levels. Here is a user ID. Well, I'm gonna show you something later about this, right? Here, this is a logical variable, so it's why the values are true or false. What else I could do is here, if I click on this, behind the scene, it's gonna run the view command for me, right? So this will open the data preview, right? So if I just want to preview my data, and I can also use the arrows to order the data. Now, something to keep in mind that the data that I've read here is stored in memory. Any changes that I make to it are not going to be written to the disk where I've read the file from. The changes that I'll make will be affected only to the copy that I just loaded in memory. Right, so that closes. Alternatively, I could run the view command. It's very important to make sure that the command is in your script, because next time, right, when I come back to my script that I was working on, I should be able to get back to where I stopped just by running the script, right? So you want all work that you do to be reproducible. Next command, this is your friend, so to speak, head. Because sometimes you want to preview the data, and you want it to be in a format that you could just copy and paste sometimes. Notice that it wraps. When the data preview does not fit on the screen, it's going to wrap, right? Here we go. So now see this head, by default it's showing me the first 6 rows. I can change it. There is a second input parameter that head command takes, and this is a number of rows to display. So now let me go ahead and run it. There we go. So now I'm showing the first 10 rows. Tail command is the opposite. It's going to show me 6 last rows. 6 last rows, right? And here I can specify that I want to see not 6 by 10, right? Fix command, well, this will open the dataset in the edited mode, but keep in mind that it might not work on a Mac. Well, just I guess it's not as important. Just if you're using Markup, it does not work, don't worry about it, so to speak. We're not going to be using this. I'm just showing you how to do it, but that's usually not the way that you want to edit the data. You want to make the changes before uploading into R, or you want the changes to be part of your data pre-processing command, because any work that we do has to be reproducible. Now, notice here in this window, I'm showing you the data frame structure, right? An alternative way to do it programmatically is to run the str command. This is an str command. It shows you the variable names and their data types. If the variable is a factor, categorical, right, it shows you the valid values. See this? So this is a drinking level. And what does 1 mean? Basically, you have 3 values, right? This value here is referenced as 1. this value here, casual drinker, is going to be 2, and the next value is going to be 3, right? So that's what it means here. Class is going to return me the data type. Earlier, it returned me the class of X as integer. Here is going to be the data frame, right? Here, this command is data frame is one way to check if my variable is a data frame, and it's going to return true. Now, keep in mind, what is it here? This output is a vector. It's a vector of one element, and this is an index of the first element, which is 1, right? Now, to get the names of the variables, right, the variables in the data frame, there is a command called names. I can run the names command. It's going to return me this variable names. Here, notice that this is also a vector. And in the brackets here, I see the index of this element, the first element that is displayed in the row. The index of this element is 5. Index of this element is 9, and so on. Now, there is another property called attributes. It's going to give me the variable names and the row numbers. It's possible to name the rows, but by default, the row name is just a row number, right? So what is this? Secretly, this is called a list. This output right here, it's a list that contains several elements: name, row names, and class. So this is a list, right? This is very important because a lot of commands return the output that is a list. You will see it in the upcoming lessons. Now, so here it is. Now, what you could do is, if I'm only interested in the variables, right? If I'm only interested in the variables is the first element of the list, right? So I just do this. I do attributes, user profile, and do 1. It's going to show me only the first section right here. So there is more than one way to get the variable names. One option is to run the names commands. Second option is to do the attributes and to take this first element. And column names command is another option. Right. Now we're going to get to the dimension. Dimension is the number of variables and the number of data rows. DIM command, right? DIM is going to give me my dimensions. In this case, I have 131 data rows and 17 variables. What if I'm interested only in the number of rows? I can do nrow command, right? I can do that. Or alternatively, remember this output is a vector. And the number of rows as the first element is in a vector. So I can just do this. I can display only the first element, right? This, here it is, right? To get the number of variables, I can do encall, and I can also do the length, right? I can do the length, or I can do dim command and take the second element. Now, this is something different. Look at this. Do you remember names? Names returns there's a list of variable names, right? And now I'm running the length command on the list of variable names. Now, do you remember? Do you remember it? Names, right? It's going to return this names, right? It's going to return, and now I'm taking the length, so it's supposed to be 17. Right? So that's another way to see how many variables are in my data set. Now, here is another command. This is also your friend because it's going to display summary command. It's going to show you the statistics, the properties of each variable in the data set. The statistics that you see depend on the variable data type. So, for example, smoker is a logical variable, rather, right? So the values are true and false. It's going to show me how many instances in my data set have each value. Here, drinking level, this is a factor variable, and it has 3 values. It's going to show me the number of instances that has each value, and so on. But let me scroll down to this variable here. is a numeric. It's going to give me minimum, first quartile, median, mean, third quartile, maximum. And what is this? NA, it stands for the number of missing values. As you may remember, this is what I showed you. This file here, this is a missing value, right? So it's showing me that my data set has one value missing for this variable, right? So now notice here, this variable color, it has more than 6 levels, right? It's showing me the 6 dominant levels. By default, it's going to show me 6 dominant, right? And other, it means that the remaining values. I have 15 instances that have a value not listed here. It's showing me the dominant, right? Now, alternatively, suppose that I have 200 variables, and I'm interested in statistics for only one variable. Do I have to scroll through the list of 200 variables? Of course not. I have a solution. I can display the summary only for one variable. So to do that, I have to put my data frame name, I put a $sign, and I put the name of my variable, right? Now, this is something nice about R. Suppose that I don't remember how I spelled it. When I put the $sign, it's going to give me the pick list. See, this is that nice. I can limit my pick list further by typing W. See this? It's a type ahead feature. It can be enabled or disabled in the options, but this is something nice. So now I made a change to my script, right? If I make change to my script, this becomes red, and you see the little asterisk. It means that the last change is not saved. To save it, I just hit save, right? So now let's run the summary command. There we go. So this command showed me the statistics only for the variable I'm interested in. And what is this? This is a comment, right? I put comments in my script. This part of the line is comment. It just got echoed here, right? So now, here, this is another way to display the summary for all variables in the dataset. lapply. lapply function allows applying the specified function on all variables in the dataset. I get returned almost the same information that this command returns. The only difference is that the different layout. The layout is different, slightly different, right? So basically, there is more than one way to do this. Here, I want to see the minimum birth year, right? I just want to know. I just want to have an idea on what the oldest person is and what the youngest person is, so to speak. So let's first try to do the minimum, right? So that's going to be the age when the oldest person in my dataset was born. And here, range is going to give me the minimum and maximum value, right? So this is a range. This range, right? Well, actually, not this range, a standard deviation, actually. Standard deviation is not part of the output of the summary command. To see the standard deviation, you have to run SD, right? Now here, unique is going to show me the unique values. It's good for the categorical variables. And it's the same thing as levels. It's just going to return me what the possible value of activities are. So professional, student, unemployed, and working class. Now here, this is a little bit different. It might take some time to understand, but now suppose that I want to see the maximum birth year, but I don't want it to see just the maximum birth year. I want to see the maximum birth year per activity. So I'm going to use aggregate, but here I want to specify user profile, birth year, because this is what I want to see, and the function is maximum, but I want to see it per activity. So this is how it's done. This is a variable that I want to aggregate. I put tilde, and then I want to specify what I want to aggregate it by. All right, so I hit run. There we go. So here it's showing me for activity, right? This is just an example, and this is going to be probably the youngest person. It's going to give you an idea, because see, that's a birth year. And later on, later in this demo, we're going to use it to add variable age to data frame. We're going to use this birth year. So next thing on the list is subsets. To take a subset of the data frame, we need to specify the range, rows range, and the columns range, right? So here, this is how you output the first 5 rows and all variables. So basically, the first element here is a set of rows. The second element is a set of columns, right? Like over here, for instance. Let's say here. This might be a little bit simpler to understand. So here, I want the first 5 rows and the first 6 variables, right? This is what's going to happen. But here, if the variables are omitted, it's going to take all variables. Here, it's going to take all variables in the first 5 rows. Okay? That's what it's doing. Here, I'm going to create a variable called new user profile, and I'm going to assign the first 5 rows and all variables. Right? So here, notice that I just displayed. Here, I'm going to assign. When I assign, I don't get the output printed to the screen, but to see my output, I would have to do, you can either run the print command, right? You can do print and then put the variable name in parentheses, or you can just enter, you can just type the variable name, right? Now here, this is what I want to do. This is a little different. I can specify, this is an alternative way to specify the first 6 variables. I can just do names, user profile, names returns a variable name, and I want to take the 6 variables. These 2 commands are going to return the same result, right? This will return the same result. Here, what I'm doing is that I want to get variable at position 1, 4, and 5. Do you remember a little earlier tonight I showed you this? This is a list, right? Combine command is a list. So this is where it is useful. I can take the subset of columns here. This is 5 rows and columns 1, 4, and 5. That's what it's doing. Right? This is a subset. Here, I'm going to take the variable names, right? I want to take first 5 rows, and I want to take these are my variables. Right? Here, what I'm doing is I still want to take 2 variables, but I want to take all rows because this is omitted. Right? Here, what I'm doing is I'm taking just 1 variable, smoker, and I'm taking the first 4 rows. Smoker, first 4 rows. Right? False, false, false. It's because if I look back here, if I look at it here, the first 4 rows, the values are false, right? So this is how you access one variable. You put the $sign. Here I'm specifying the condition, right? I want to select the rows with a birth year above 191, right? And I want to select all variables. This is a conditional selection, right? And this is the combined condition. See this? I want to have users born after 1991 and medium budget. This is a compound condition. So now what I'm going to do is I'm going to show you how to add a variable. Sometimes the birth year might not be really useful for results interpretation. I would rather see an age. So to add a variable to the data set, what you do is DataFrame. You just put the DataFrame name, you put a $sign, and you put the variable name. In this case, I want to call it age, right? And here is my assignment operator, and I'm going to say age equals 2017 minus birth year. Right? I'm subtracting 2017 minus birth year. So, and this comes my friend, my head command. I would like to preview the first 6 rows. This is age, right? I just added a new variable called age. Now, sometimes we want to delete a variable. Why? Because the data set, notice that it has a unique identifier. Unique identifier might not be really useful for analysis because it's just a number. It's not really, it does not really tell us if, perhaps if I was going to predict if an individual is a smoker, a unique identifier number does not provide us useful information, right? Alternatively, your dataset could have variables that could expose the sensitive information, such as social security. So that's one reason for removing the variable. Then it's highly possible to have a variable that has the same value for all instances in the dataset, right? Like, for example, if my dataset has data on all smokers, variable smoker would not make sense, right? You would also want to look at skewness. For example, suppose that I have almost everybody is a smoker and one person only non-smoker. It's not really helpful. Or you could have a variable where more than half of data is missing a value. That's one possibility, right? But in this case, I have a unique identifier, so I want to remove it, right? So that's one reason. Now, let's go to sorting. Here, the task is I want to see the 10 youngest people. How am I going to do it? I'm not interested in 10 youngest ages. I'm rather interested in the people information. I want to see the information about 10 youngest people. So, I have to use the order command here to specify the variable I'm sorting by, right? So remember here, in brackets, I'm taking all, I want to take all data sorted by the age and all variables, right? Here, I'm not specifying which variables I'm taking, so I'm taking all of them. And here, I'm specifying the order of data. I'm taking it by age, and that's going to be ascending. The default order is ascending. I'm creating another data frame called user profile sorted, and I'm assigning, right? So now, if I run the head command, I should see 10 youngest people. So why do we want to sort data? This is one problem, where I want to see the data about 10 youngest people, right? Sometimes the sorting could also reveal the missing values. It's highly possible that the instances with missing value could be either at the end or at the top, depending on how you specify the sort order. Sometimes it's highly possible that it could reveal duplicates. But the main reason here is I want to see the 10 youngest people. Here, I can do the opposite. I can sort descending, right? To do descending, I have to put a minus sign in front of the variable. So this is going to do descending, and then I'm going to run the head command to preview. So whenever you're asked to do the sorting, you also want to run the command to verify, right, that the sorting worked as expected. You want to always check, right? And here is how to sort by 2 variables. So suppose that I have 2 or more users of the same age. I want to sort users with the same age also by weight, right? Or how much they weigh. There we go. And now I want to preview, right? So that's basically about the sorting. Now, this is the factor variables. I want to show you a little bit more about the factor variables. Here, well, it's not something that I want to do, but I'm just showing it for the sake of how to do it. To convert the numeric variables to a factor, well, first of all, you want to look at it. you want to look at it. Is my variable actually continuous number, right? Is it meant to be a continuous number? For instance, birth year, it actually is. I should not be doing it in reality, but I'm just doing it just to show you how command works, right? So if I do this, if I do something like this, my variable data type would be converted to factor, right? But that's not something that I want to do. I just put it here for the demonstration purpose. But in general, for the birth year, I don't want it to be a factor. On the other hand, it's not really numeric, right? Because can you do multiplication? Can you do the division with this? Can we do... Well, the thing is, sometimes we need to look at the definition of the problem, right? But I'm just showing you how to do it. So now I do summary. Take a look at it. This is a problem, right? How many levels do I have? Too many levels, right? So if I was going to keep it as a factor to do my analysis, I may need to group some of the values. If I was doing this for my analysis, I would probably have to group these values that are below 180. 100. See, this before this year, I would probably want to group them all together. Well, something like that. Now, let me show you something else. I could record my factor variable. So here what I'm doing is I'm creating a new variable called new user profile, right? Levels. Here, my values of the budget are high, low, medium. And here I'm just showing you that I can change it. I can change HML, and then I'm gonna just do the summary of this variable and then change it. Basically here I'm just showing you that it's possible to record the values of the factor variable. This is just for the demo purposes. And here levels, it's just gonna show me the new values, right? Now here let me show you something else you can do with the factor variables. You can do the frequency count. Table command is gonna count how many instances have each value. Okay, table. Here we go. So I'm saying that I have, this is a variable called transportation. I have 41 people who own a car, 15 people who walk, and 82 people who take public transportation. That's what it's doing. Here, prop table is going to show me the proportion. I can do the proportion, right? What percentage of people own a car, so to speak. Here, I put two variables. It's going to do the crosstab, right? So here, the way you read it is that I have 8 car owners who are married, 32 car owners are single, and 1 car owner is a widow, and so on, right? This is how you read it. This is a cross tabulation. And alternatively, I can switch the order of these two variables, right? I can switch, right? I can display it this way. Here, I can also do the proportions, right? So this is a percentage of people who own a car and also married. And I can do rounding, right? And I can do another rounding, right? Because I want to see the whole number. Now we get to a very interesting topic, the topic missing values. As you may remember, I showed you that we have here one instance, height and weight are missing. They're just not there, they're unknown. So now, why is it a problem? Let me show you. I have a function. I want to take the mean of the weight variables. What am I going to get right now? Surprise! NA. It does not handle the missing values. What I have to do is, explicitly, I need to tell my command to ignore the missing value. And a.rm equals true. This will force the calculation to ignore missing value. Now I'm going to show you some useful commands that you might like, and I'm gonna give you the copy of this file. After this presentation, you'll have a copy of the file. So here, any command is an A. Basically, is an A checks if the value is missing. Any will check if there is at least one missing value in a data frame. Any is an A. It's going to check if there is at least one, right? It's going to return true. Here, sum is going to return how many missing values I have, right? I have two missing values. Because basically, if I just run this part right here, if I just run this, what it will do is, for every data row and for every variable, it's going to check if the value is missing. See this? If the value is not missing, it's going to put false. If the value is missing, it's going to put true. It's going through all variables and all data, right? All instances. That's what this part is doing. Any is going to tell me if there is at least one true value. Sum is going to be how many. Here, I want to check only the weight variable, right? How many are missing. Here, I want to see which, right? This is observation number 16 is missing a value of the weight variable. So if I go here, this is going to be number 16. See, this row 17, but the first row is variable names. So this is showing me that this observation is missing a value for the height. Sometimes it's really useful to see which one. Now, here I want to display the observation if at least one variable is missing a value. Complete cases part is taken which cases are complete, right? This by itself is going to give me which instances don't have a missing value. Exclamation point is a negation, right? So here, that means not, see this, not complete case, right? Incomplete case. This is a condition for the rows. And here, I don't specify which columns, everything, right? I want all columns. And there we go. Here is my variable, which has a missing value, right? I have two missing values in the same observation. Here, this one, it's going to give me how many missing values, right? Is an A. Hold on, let me run it. So it's going to give me for each variable how many values are missing. This is per variable, right? Call sums takes the sum, right, of values in a column. This is an A. It's going to return true or false. Do you remember? It's going to return for every instance. For each variable, it's going to return if the value is missing, right? And call sum is going to count the number of true values, right? So true, see this height. It means one instance is missing a height value. Now, how do we handle the missing values? That's a question. How do we handle the instances with missing values? What we need to keep in mind is that how many instances are missing a value? What is the dataset size? Is it just one variable that's missing the values, or is it multiple variables? The data mining methods that we're running, how does it handle the missing values, and so on. There are a lot of considerations that we need to keep in mind. But in general, an A omit will eliminate the data rows that have missing values. So here, it's going to create, I'm creating a copy of user profile, and the copy is not going to have the rows with missing values. So this is my data frame, notice that here, and I have 137 observations. It's because it's I dropped the observation with missing values. Remember, I have one observation with missing value. I dropped it. This is an alternative way to do it. I'm taking the complete cases, right? Here, I'm specifying which rows to select, and here which columns. So there we go. Here it is. So it's going to produce the same result. But I'm just showing you that there is more than one way to do it, and you choose it. Now, this is a numeric variable, and I have only one observation missing a value. What I could do is I could replace with a variable mean, right? So how do I get the variable mean? If I just do this, is it going to work? I don't think so, right? I don't think so because there is missing value. So when I take the mean, I have to tell it to ignore the missing value, right? So this is on the right side of the assignment operator. I'm going to take the mean weight and I'm going to ignore my missing values. Here, I'm saying that I want to replace the weight values that are blank, that are missing. Is an A, what this is going to do, is an A, it's going to return if the value is missing or not. If the value is missing, it's going to return true. And if the value is not missing, it's going to return false. So see, this number 16 is an index of this value. And this is true. Remember, row number 16 has a missing value. It's going to return true, right? So I want to take the row number 16 and I want to replace the value with the mean, right? This is what it's going to do. And I'm going to run this. And this is an alternative way. Sometimes I want to set the missing value to the user-defined value. So this is alternative. I could set it to 5. Well, it all depends on your business problem, right? Here, if I'm going to run a summary command, I'm going to see that it no longer shows that I have missing values, right? Or alternatively, this is what you need to do is you can run this isAnA command, right? To show that the missing values are gone. Oh, wait a minute. I only took care of the weight. I didn't take care of the height. So let's go ahead and take care of the height. This is height. Now, 5, okay, that's probably 5 foot, right? So let me go ahead and run. There we go. So this is just a business rule. I said I want to set missing to 5. That's one way. So now to verify that the missing values are gone, this is one way. Or alternatively, I can go back up and run my any command. Remember it? I can do this, and this will show me if I have any missing values, and it's going to be false, right? It's going to be false. So now, next topic is packages. So here is my packages tab. That's what I want you to notice here. First of all, very important, when you download this new version, right, this new version 3.40 is a recent update. If you use an older version before, and if you installed packages before, doesn't matter, you'll need to install them again. You'll need to install the user library packages again when you install the version 3.40. That's something to keep in mind if it's not your first semester using R. It's highly possible. All right, so here you have a user library and you have a system library. System library is a set of packages that are pre-installed. They come with RStudio installation. The problem is that the pre-installed packages do not include all functionalities that we're going to use. So you would need to install some packages, right? Here, this is a very useful command because it's going to take you to the URL that lists the available packages on CRAN and their description. So let me run this. It's supposed to open the browser, whichever your default browser is. And this is a web page that shows the description, right? Here it is, see? So this is just, you can click and read more about each package. Now here, it's going to list the packages that I have installed on my computer, on my R version. That's what library does. It opens a separate window right here, and it shows me my packages. Of course, your output is going to be different. And search is a list of loaded packages. So basically, when you have a package installed, the package is not available until you actually load it in memory, and I'll show you. So here, this is a command. I'm not going to run it because I already have this package installed, but you would need to run this, right? A rules package is a package that is used to do association rules and to do the discretization. In this demo, we're going to use the discretization and explain what it is. So a rules, this is a user library package. It's not pre-installed with R, and you have to run this command to install it. Now, the package is not available until it's loaded in memory. To load this in memory, there are two ways. You can run the library command, or you can run require command, right? Notice that this checkbox over here is checked. Alternatively, you could just check this checkbox, right? To load the package in memory, you can just check the checkbox. And if I do this, R is going to run the command for me on my behalf, right? But the problem is the work that I'm doing today, I want it to be reproducible, right? So what I want to happen is that if I do it this way, I would have to make sure that my command is added to the script, right? Well, okay. So this is very important. You want to make sure that your script is the work that you do is reproducible. So if I was going to pick up tomorrow from where I stopped, I want to be able to do that just by running a script, right? So now here, let me show you something. This is also important. There is a help page about the package. Well, in general, if I want to see the help page for any of the command, right? Like for example, I want to see the help page for the head command. I'm going to run the question mark and the command name, right? There we go. So here, it just lists me the packages, right? It just lists me the packages because it found this command in more than one package, right? So let me run different. Let me run summary. Basically, what I'm saying is that when I run it, it's going to show me the help page for the command. Or if more than one package has a similar command, it's going to give me an option what I want to see. So here is a command. This is a package, right? Package where the command implementation is. This is the command description. And then I have some examples on how to use this command. And this is the input parameters that the command could take. And some examples, right? So this is a help page. Now, here you can also see the help page for the package, the documentation. So to do this, you're going to do the library command, but here you're going to put help, right? Library help. So what this does is, it displays the package information, something similar to what I see in the help page. But it's going to list the method names, right? So that's one way. Alternatively, I could go here and I can click on rules. This is alternative way to get this information. But here I've got links, right? I can click and navigate to each specific method description, right? But I don't have it here, but well, this is more if you want to copy and paste, so to speak. So let's close this out. Now here, some packages come with VNet. VNet is a set of, so to speak, example on how to use the package. So if you run the VNet command, it can show you the examples, like here, for instance, right? So if you're taking an introduction to data mining course, this association role method, it's probably week 3 of the course. Here you can alternatively see VNets in the browser. And this command, I'm not going to run it right now, but this command will get you the most recent version of the packages. Remember, you need to keep up with updates. You can do it programmatically by running this command, or you can also do this check for packages update. You can do that too. So I made this a habit. Every few days when I launch RStudio, I just do that to make sure I have the latest version, right? And here you could also do this click here update. That's another way. Now, this is how you would unload the package. You can run the detach command, or alternatively, what you could do is you could uncheck this checkbox. Well, okay, I got an error message, but it does not matter in this case. But if I was running a demo on this package, I would have to do some debugging. But for right now, right? In order, if I want to uninstall the package entirely, I would run this command, or alternatively, I could click on the next here, right? So now we get to the discretization, and here I may need to show the slide to explain it better. But the whole idea is that variable weight is a continuous. The values are continuous numbers. Some of the data mining methods, such as association rules, do not handle the continuous variables. The variable needs to be categorical for the method to work. Factor command is not going to work in this case because the values of weight are continuous numbers. We don't know how many valid values are there, right? So I have to use an alternative approach. Discretize command is implemented in a rules package. So you have to load a rules in memory to be able to use the discretize command. Discretization command has several options, and I summarized the options in a slide. This is the same presentation that you saw displayed. I summarized the options in the slides for you, and you're going to have the copy of the slides. So, one option is you have an equal interval. Basically, I want to divide my values into the same value ranges, right? So I go 40 to 56, 56 to 72. The ranges are approximately the same, and I want 5 ranges. It does not matter how many instances have a value in each range, right? So that's what it does. It's equal interval. It does not matter how many instances fall in each bin. This approach could be sensitive to the outliers, right? And, however, it preserves the distribution. It preserves, if my data is skewed, it's going to preserve the skewness. Because if you run the histogram, if you plot the histogram for this variable, for the weight variable, you see the skewness, right? So this is preserved. Another alternative is equal frequency. So I want approximately the same number of instances to have a value in each bin. So here the y-axis, it shows the frequency, right? So I'm using the frequency, and I want to have 5 bins. I just picked randomly the number of bins, but something to keep in mind, some methods that you're going to run could be sensitive to the number of bins you choose. And to determine that, you would probably need to look at the histogram, you'd probably need to look at the distribution, and more. Now this is not as sensitive to the outliers, but it does not preserve the data distribution. Alright? So, well, you may say it's not exactly the same number of instances, but it's approximately the same. And here, cluster method. So basically what it does is it randomly selects the 5 cluster centers and will try to position each instance to the closest center. So this will preserve the distribution, but it's sensitive to outliers, right? Because what outlier is an extremely large value or extremely small value? Like, for example, suppose I have people who are about 5 feet tall or 6 feet tall, something like that. Suddenly, I have one person who is 7 feet tall. That person is probably an outlier, right? So it's an extremely large or extremely small value. Here is a fixed method where I can explicitly specify the boundary points. Well, sometimes I want to do it. It depends on the problem that I want to solve. Well, the beans, they don't have to have an equal width. They don't have to have the same number of instances. This is my choice, right? So this is a discretization, and I can just go ahead and run it just to show you that it runs, right? And now here I can just do the summary command. So if you are asked to run discretization method, perhaps in your homework assignment, then you would need to do the summary command afterwards just to show that the command worked, and you would need to explain that instead of seeing the minimum, maximum, medium descriptive statistics, you now see the value ranges and the number of instances with a value in each range. And here I'm using an interval, so basically I can say that the interval have approximately the same width, right? And the number of instances is not approximately the same. Now here you may notice that the curly bracket, it means that 56 is excluded. Square bracket means 56 is included, right? And I can look at this. So this is one way to validate, right? Here we go, right? INF stands for the infinitely negative number. This is the favorite part for some people, data visualization. I'm going to show you some of the visualization methods and also when do you use each method. The histogram, they show the frequency for numeric variables. It's very important to remember this is for numeric. There we go, right? What you want to play around is you want to play around with different options such as colors and the number of breaks. By default, it will try to optimize the number of breaks for you, but you can change it. You can override it. Breaks input parameter, for instance, well, it's not necessarily B20, but you can try it, right? Alternatively, you can change the color, right, by using COL input parameters, but I'll show you color shortly. Now, what you could also do is bar plot. For the bar plot, you have to put you need to use the frequency table as an input, because bar plot is used to show the frequencies of values for the categorical variable, right? So now remember this. I'm going to use, there is more than one way to do this. In my case, what I want to do is I want to assign this frequency to a variable. I want to store it in a variable, right? So this is frequency counts. I'm going to show you something extra here. I want to plot it, right? But I want to plot it sorted, right? I want to do this. So here, what I'll do is I'm gonna sort it. See this? I do order. It means sorting the ascending by height, right? I want to sort this by the bar height. Now notice that some values do not show, but if I zoom in, I'll see them. Right? Or if I resize the window, I'll also see them. Here is how you show the horizontal bar plot. Right? Here, pie chart, you use it to show the frequencies of the disk. You want to show it the frequency distribution of the categorical variable. Caution, could be hard to read. Sometimes the pie charts could be hard to read. Well, in this case, I can just do zoom in. It's not a problem. But the problem would have been if I had multiple categories, if I had 50 slices perhaps, right? That would be very difficult to read the labels. So in that case, you would probably want to switch to the bar chart. And this is a box plot. This is for the numeric variables, right? Box and whiskey plots. Now here, this is a generic plot function, just generic. Here is going to do my input parameter, right? This is a categorical variable, right? Personality is a categorical variable. It's going to do the bar plot for me, right? Age variable is numeric, right? It's going to do, I can do the line plot, but here I have to specify type equals line. I have to specify it because if I don't do this, look at what's going to happen. Oops. See this? Oh. Hold on. There we go. Control Z, Control Z, Control Z, undo. Okay. Plot. Oops. Okay. This is what happened. When you get this error message every time, when you try to build the plot, when you get this error message, do this. Plot new. And now it should work. Oops, still. I think they have that off. I forgot. Oops. Okay. Anyhow. There we go. It did it. Okay. Not sure what I did it, but looks like I fixed it. Now, so let's go back to the plot command. Plot command. Okay. Line. Oops. Still. So what you do is, yeah. So what you do is you would need to reset something. It's all right. Okay. Now let's see if I can do this one. Yes, I would have to reset. The margins. Yeah. I would have to reset the plot. Yeah. Let's try this plot new. I forgot. I used to know it by heart, but there is a command that you can run to reset this. It has an off something. Probably. Let's see. No, but anyway. So let's just do this. Just trust me, it's gonna work. So now let's try to plot the user profile. There we go. Right. So I'm plotting the height variable. So this is a single numeric variable. It's gonna show me the scatter plot, right? This is gonna show me the scatter plot because this is a single numeric variable. Here I have two numeric variables, right? All right. Or alternatively, what I could also do to fix the issues that I was having, I could restart the R session. That would have solved it. I could restart the R session. Once in a while it happens. And if I had to restart the R session, I would just rerun the commands to go back to where I was, right? So I would need to rerun the commands to go back to where I was. But thankfully, I believe some of the charts I put in the slides. Well, I put some of them, right, and I summarized when you would use them. I just summarized that here is an example scatter plot. You use it to show relationship between two numeric variables, and you use the bar plot to show the frequency for the categorical variables, right? So sometimes it's good to know which one you use. Colors. Colors command will show you all available colors. So you have a bunch of lists here. You can specify the color name or you can specify the color number. So here, this is a number of this color. Remember, it's an array, and this is the element number. So now I'm going to run this. Oops. It's because I see what's happening. So let's do this. To fix it, I could have to do this session. I can do restart R, and it's going to fix it. But okay, it's gonna fix it. Restarting R session. But when I do that, let's see, I may have to rerun the commands to go back to where I was. Well, in one sense, it's good that you saw me getting an error. So that way, when you run the commands, if you get this error, you're gonna remember what I did. Oops. Okay. I would have to look into this. So if I do this, oops, one way to do this is close, and I want to save this. And now, let me go back to run my RStudio. Let me go back. But what I'll have to do is I'll have to rerun the commands, but that's alright. I want you to see what I'm doing, so that way, if you get this error message, this is what you're gonna do. So now I'm back, right? And I'm back in my environment. Let me just delete everything. And this is what I'll have to do. I would have to go back. I would have to rerun. I would have to rerun this to set the working directory, right? And I would have to read again my variable called user profile. Now, what else did I do? I don't need to do the head command. I don't need to do the tail command. But my goal is to restore the changes to the actual data itself, right? And the changes I made was I added the age variable, right? I removed the user ID. And what else did I do? I don't need to sort it for now. What else I did? Okay, so what I also replaced the missing values, right? So let me scroll down. So here I'm just checking if I have a missing value. But in here, yes, that's what I did. I'm gonna redo this. There we go. And now it should work. It better does. Oh, I see what's going on. I see what's going on. I have to create my variable, right? So I have to define it. I did not define it. So let's do this. Let me change the variable name. Instead of age interval, I'm gonna put personality. Let's change this. Here it is. It's personality. Control C, Control V. All right. So let's do this. Let's run this now. Run. There we go. So here it is. It's a bar plot. And what I did was I specified the color. I wanted the violet color, right? And here is the same thing, but instead of specifying the color name, I'm actually specifying the index, right? I'm specifying the index. And here, it's just the rainbow colors. It's going to use the colors of the rainbow, and each bar is going to have a different color. Now, everybody was paying undivided attention. Bonus. Three-dimensional scalar plots. Three-dimensional. To do that, you would need to install a package called plot3d. Right? Since I already have installed, I don't need to install it again. But the package is not available. I have to call it, right? I have to use the library command, plot3d. There we go. This is what now what I'm going to do is I'm going to define which variable I'm using for x-axis, y-axis, and z-axis, and which variable I'm going to use for the color code, right? So I run this, 2, 3, 4, right? Now I'm going to use the plot3d. What I am going to do though, here, x, y, z, I set them here. This is a color variable. Main is a title, right? It's going to specify the title of the plot. And these are the labels that I want to see on my axis. This is how I label my axis. Plot3d, run. You have more options, so now you can zoom in. You also have more options. You can rotate this visualization. So in this case, help command is your friend. So see that this is polar coordinates. You can make this plot look different. And to navigate between plots, by the way, I can use this arrow just to go back and forth between my visualizations, right? So if you're working on homework assignment and you realize, oh, wait a minute, I forgot to take a screenshot, you can always go back. Now here, this is more fancy image, right? This is more fancy. There we go. I guess this is the image that you saw on the first slide, in the agenda slide, right? So this is just basically how you can play around with input parameters. And this is even more. I can do animation. See this? This is a package that allows animation. Then you would need to load this package in memory. And you just call this function. It's going to animate. I believe it's the last visualization. It's going to open a new window. Here it is. And you can just rotate it to get the different view of visualization. Right? So that's 3D with an animation. Right? So that was a bonus for people who attended and or for people who watched the recording of this presentation. Right now, it's your turn. I want to see questions. I spoke for about an hour and a half. So now I want to give you a chance to ask questions. So you may unmute yourself and speak or put them in the chat. Let me go ahead and see the chat. No questions so far. But yes, I like questions. And if there are no questions, Yelena starts asking questions. For example, I can ask, what do we do to make our work reproducible? Right? That's my favorite question. What do we do? To make the work reproducible, we have to what? Save the commands in the script, right? Yelena can ask you about the difference between summary and str command, right? Remember, str will show the structure of the data frame, right? Summary shows the descriptive statistics, right? So I would like to see questions. This is an excellent opportunity to ask questions, and Yelena loves questions, right? So,
guys, you better ask questions to Irene, otherwise if she starts asking questions, we'll all be in trouble.
excellent. Excellent point. Yes. Exactly. Excellent. All right. Question asked by Yelena. I forgot to show you this history tab. All commands that you type are stored here in this history tab, right? Oh, how to save your home directory? The working. Oh, Ayo, this is excellent question. I plan to show you, but I almost forgot. Thank you so much for reminder. Take a look what you can do. Tools, global options, right? It's gonna open a pop-up with the settings. For some reason, oh, here it is. Global options. Select general. Over here is default working directory. Over here, what you could do is you can browse and you can specify the folder, right, that you want to select. And if I specify explicit folder, every time when I launch my RStudio, it's going to be my working directory. But when you select it, you want to choose apply or OK because you want to save the change. How to take the screenshot in R? Another excellent question. I am a Windows user. Windows user has a nice tool. Windows has a nice tool, the snipping tool. So snipping tool, right? So I just go new and I take nice. This is a Windows. Windows has a snipping tool. But if you are using Mac, there is probably a way to take the screen print, right? You would probably need to take, well, since I'm not a Mac user, well, I would think one way is to take a screenshot of the whole screen, and then you would need to crop and resize the image in the image editor or in Word. But in RStudio, well, if you're Windows, you can use the snipping tool. That's the tool I use when I put together the handouts for the students. Another option, if it's a plot, right, this is my plot, what I could do is there is an option to export, and you can save your plot as image, or you can copy your plot as a clipboard. So if you copy the plot as a clipboard, then you go to the Microsoft Word, you can just paste it, right? That's another way, right? So, yes, so this is history. To run the command from the history, I can just do this. I can highlight my command, right? I can go back. I can highlight my command, for instance, right? And here, for instance, I highlight my command and I do to console and I hit the enter key. That's going to run the command, right? And now something else I forgot to show you. Your friend is up and down keys on your keyboard, right? So if I hit the up key, it's going to show me the command that I ran before this command. And if I hit, basically up and down arrow allow navigating through the history. Here, if I select a specific command, if I hit this delete, it's going to delete the specific command. And I have a broom, it's going to wipe out the whole history, right? How do I clear the, to clear the console, there is more than one option to do that. You can do there is a command that you can run to clear the console, and I believe it's, well, I can find it.
Control L.
Control what?
Control L.
Oh, thank you. You're my lifesaver. Control L, yeah. Control L. There we go. Control L. Yeah. But I think in Mac it's gonna be Command L, right? Because there is no control button in Mac if you're a Mac user. Yeah. But of course there is more than one way to do the same thing, but yeah. This is excellent question. I love questions. It really helps you and it helps everybody, right? So, and also, yeah, to make sure that I did not forget anything, we can go quickly through the slides. So, I showed you the data set. I went over our advantages, disadvantages, right? We went over different screens, right? And you're going to have this copy of the slides. We went over the help file. So, basically, I put a question mark and the command, and it's going to show me the help page for my command. This is your friend. Then I went over the working directory, and this is actually the answer. I anticipated that question. So I will make sure that you have this slide, and this is slide number 12. It shows how to change the default value of the working directory. Right? If you're not using the R project, there is an option to create a project, but yeah, that's something interesting to try. Anyhow, here it's showing you the approaches to preview the data set, right? So you can do the view command, or you can do the head, you can do the tail, and so on. This is the str command, right? Here, I went over this, right? How to check if it's a data frame, how to check the variable names, number of rows, right? We went over this. We went over taking subsets, right? We went over how to access a variable, and we went over how we delete a variable and the reason for deleting, right? And here is a summary on how we do the descriptive statistics, right? Sorting. And one example that I showed you is we want to see 10 youngest people, not just 10 youngest ages, but people. And here is what we can do with the factor variables. We have the frequency counts and so on, but this actually sets the stage for the bar plots and for the pie charts because it takes the frequency table as an input. And this is missing values. Well, basically, what I did, I just put together the presentation. It's also helpful as an outline. So I'm looking through this to make sure that I covered everything that I want to cover. Looks like I did, yes. So here, basically, I'm showing you how to install packages. Remember it for the assignment that you're doing. When you're running the discretization, and if you get an error message, right, that the function doesn't exist, something like that, more likely it's because a rules package is not loaded in the memory, right? Uh, Here, additional useful commands such as library. This is how you see all installed packages and all loaded packages, right? And here I'm explaining discretization, and I showed you these two slides, right? So it basically shows you when you use each method. There is no right or wrong answer, but few things to keep in mind. And I went over different types of plots and when you use each one, right? This is just the code, but here is a little simpler version of the code, right? I did not put fancy rotations and so on. Now, what else I did for you? There are some online tutorials that you can take, and you may actually practice. Some of them are sets of videos, and some of them are basically you go in and you actually practice as a hands-on. You would like the try-R. It's set up as a game with multiple levels, and your goal is to get to the next level. You do that just by mastering the R commands. So this is a little bit interesting, but while you're doing it, the learning takes place. Trust me. So here are free ebooks. I just put some links. And these are some web pages that you might want to bookmark. The web page where you download the R. This is a useful web page. R data mining, some helpful resources. And we've got some documentation pages. It's available online or through the help, right? And you've got some question and answers, right? So basically, in your homework assignments, Google is your friend too, because if you take error message in Google, copy paste, you can get answers. Never know. Now, do we have questions? Anybody? Any questions? I have a question. What is the presenter's name?
Hey, Chandra here. Sorry, can you hear me?
Yes.
Okay, I have a question regarding the version. So whenever I start our studio, it says like I have the version 0.99 and 903, and a latest version is available. So is it okay to download and upgrade to the latest available version?
You mean for the R you would need to install for the R you use the desktop, you install the latest one. Install the latest one.
Install the latest one. Okay, so it's not going to change drastically, right? Whatever.
There are some changes. All homework exercises have been edited for the latest version, and
Okay, that's
there
what
are a lot of changes. Yeah, such
Thank you.
changes. Yeah, you're welcome. Yeah, the changes apply to anything that has to do with matrices, association rules, text mining also. The latest R version 3.4 introduces text mining. Oh yeah, somebody remembers my name. I see it in the chat. Excellent. Somebody remembers my name. All right. Anyway, so yeah, let's ask questions. I like questions. This is your turn. Take it while you get it. Questions. I realize it's a lot of information, but there could always be the follow-up questions. So the question and answer session does not end at the end of this WebEx session, so to speak, right? There could be follow-ups, I'm sure. All right. Oh, you're the most welcome. You're the most welcome. Yeah, we had some technical difficulties in the beginning, but the recording will be slightly edited just to remove that part, but we figured it out. All right. Oh, you're the most welcome. You're the most welcome. Sheila, you're the most welcome. Thank you for joining. All right.
Thanks, Elena. That's great. Thank you.
Yeah, I'm gonna stop sharing. I'm gonna stop the recording. Okay. Think. Where is it? Looks like they changed the interface. It's recording.
Yelena?
Yes, where do you stop the recording? Oh, yes.
Where do we get a copy of these slides?
Oh, I'm going to give the slides. You will
Okay.
have this. Oh, here it is, recorder. The interface has changed lately anyway. You're gonna have the copy of the slides, and you're gonna have the R script. All right? Sounds fair? All right.
Excellent.
Sure.